Hi everyone. So today we will be working on the first topic for chapter 1, which is on problem solving and critical thinking. And that topic is inductive and deductive reasoning. So for this lesson, we are going to understand and use inductive reasoning and at the same time understand and use deductive reasoning. So, what is inductive reasoning? So, it's a process of arriving at a general conclusion based on observations of specific examples. So, in simplest terms, you are making a generalization, a conclusion based on what patterns you have observed, what examples you have seen. All right. So, when we have what we call as a conjecture or a hypothesis, that is the term that we use for the conclusion. So this conclusion may be true, it may be false. It depends on how good we look at the on the patterns, or depending on how many observations we have made. Now, if ever we are able to have a conclusion, but there exists one example that will make that conclusion false, that is what we call as a counter example. Okay, so just one incident that can make the conclusion false, then that would be a counter example. We'll get to this in a few. So, like I said earlier, your inductive argument can be strong, can be weak, depending on the number of observations that you may have. So, for example, men have difficulty expressing their feelings. So, this is the conclusion. Why was this the conclusion of the speaker? Neither my dad nor my boyfriend ever cried in front of me. So why is this considered as a weak inductive argument? So as you can see, only the dad and the boyfriend were the observed scenarios, and having two examples, having two observations is not good enough to make a generalization about men having difficulty expressing their feelings, okay? So it is important that for you to have a strong inductive argument, there should be a large random enough or random samples that would be easier to make conclusions on. Okay, so the lesser your observations, your argument, your inductive argument will be considered as weak. All right, so looking at this pattern, so here we can take a look at our observed numbers. So we have 3, 12, 21, 30, and 39. So like I said, for us to be able to create an to use inductive reasoning to make a conclusion, we need to see a pattern over here. Now, if you take a look from 3 to become 12, you have two ways to make that happen. Either you add by 9, 3 plus 9 is equal to 12, or 3 to become 12, it could also be times 4. All right? So now, which of the two will be our conclusion? Well, it depends. Whichever is the consistent pattern that we see here, that's what our conclusion will be. So from 12 to become 21, how can we make that happen? So basically, we add 9. If we multiply 12 by 4, it's not going to be 21. Now let's see if it will be consistent to adding 9 every time. So 21 to become 30, again, we add 9. 30 to become 39, again, we add 9. So seeing that the pattern is plus 9, plus 9, plus 9, plus 9, can we make a conclusion that this number missing here is simply 39 plus 9? So what we have here, looking at the pattern, 39 plus 9, this is going to be equal to 48. All right? So that is how you can use inductive reasoning, and then how you can predict values based on the patterns that you have observed. Now let's take a look at this one. We have 3, 12, 48, 192, 768. Again, we can look at the pattern, how we can make 3 to become 12. So we've mentioned earlier, it is a plus 9 or 8 times 4. So this works for both. Now, from 12 to become 48, definitely a plus 9 is not going to work, which means we can apply the times 4 over here. Now, using your calculator, we can check 48. If we multiply it by 4, will it become 192? Yes, definitely. And if you multiply times 4 again for 192 times 4, you will get 768. And so given this pattern, we can say that if we multiply 768 times 4, then using your calculator, you can try that. This number that we are looking for is 3072. All right? So that is how we can use observing patterns. We can make a conclusion and then predict a value. So now let's take a look at this next one. Okay? So as you can see, we have here a picture, an optical illusion. So it depends on how you are looking at it. You could either be seeing a goblet, so the goblet is the white area, and then it could be two faces looking at each other. So if you're going to look at this shadow or the silhouette, that's how it will be. Now, let's take a look at this pattern. We have 1, 2, 4. How are we going to predict the next item or the next number? Now, this could be very tricky because there may be more than one solution in here. So if you take a look, we have 1, 2, 4. If you look at addition, so you can have this as 1 plus 1, all right? And then 2, you will add 2 to it, okay? So the next pattern, oh, you have a plus 1, plus 2. Then you can possibly conclude that, oh, this is going to be a plus 3, okay? Which means the fourth number could possibly be a 7, all right? That's one possible way. Now, is there another number that we can use? Or is there another possible answer that could be? So if you have 1, 2, and then 4, okay? One way to make 1 to become 2 is to multiply by 2, correct? So if you multiply by 2, 1 times 2 is 2. 2 to become 4 is also 8 times 2. So if we're following this pattern, 4 times 2 is going to be 8. So the question now is, Miss, which one is the correct answer? Actually, there's no correct answer because in this case, we need another example, another item over here in the sequence, another number in the sequence so that we can concretize what is the more reliable conclusion. So as you can see, having only 3 will not be enough. If we have a fourth number, then we can establish the actual pattern for this particular sequence of numbers. Okay? Now let's take a look at this one. We have 1, 1, 2, 3, 5, 8, 13, 21. Actually, this is what we call as the Fibonacci sequence. Fibonacci sequence. Okay, so this is a special type of sequence wherein you will be adding the previous number to get the next number. Unlike the examples that we had earlier, we're multiplying the same number or adding the same number. This time, we are adding the previous number to get the next one. So if you take a look, 1 plus 1, you get the 2. All right? Now, if you get 2 plus the 1, you will get the 3. Okay? And then if you add 2 and 3, you will get the 5. And you can see the pattern here. If you add these two previous ones, so it's going to be a 3 plus 5, and you'll get the 8. 8 and 5, you'll get the 13. And then 13 plus 8, so you have 8 plus 13, that would be a 21. Sorry, this is going to be 8 plus 5, yes. And then, so we know that we're adding the previous two numbers, so it's going to be the sum of these two numbers. So it's going to be 13 plus 21. So that will give us, so 3 and 1, that's a 4. 2 and 3, 2 and 1, that's a 3. So we can say that the next number in this sequence is a 34. All right. So again, there's a name for this, and that's the Fibonacci sequence. Now, this is one of the most common, this is one of my favorites, looking at patterns. So as you can see, you have circle, square, circle, square. So we can determine that the next one would be a circle. And of course, we will divide it into 4. I'm sorry, I'm trying my best to get these pictures on. Now, take a look at where the dots are moving. So this dot moved over here. So we can see that the dots are moving counterclockwise. So one dot, and then up, and then left. So it means the one dot is here downwards. So it's moving counterclockwise. So we know that the dot is going to be here. And then everything else will follow. So 2 will move over here. And you will notice that this is exactly the same as the first picture. So deductive reasoning, on the other hand, is the opposite. So earlier when we say inductive is when you have examples or observations, and then you can make the conclusion. All right. It's the other way around with deductive reasoning. With deductive, you have a conclusion, all right? And what you do is you can identify examples, okay? From a given conclusion, you can give examples, give scenarios. So that's the opposite, okay? So for example, in this case, the conclusion was you cannot use Texas as a word in Scrabble. Why is it? So the general statement is all proper names are prohibited in Scrabble. So this is the conclusion, okay? This is the conclusion. All proper names are prohibited in Scrabble. Now, having the word Texas, that is identifying an example. So Texas being a proper name, what else? Let's say Joseph, that's a proper name. So you cannot use those names, those words in Scrabble, okay? So now if you take a look here, this is very common in one of those puzzles, something like that. So you are given 4 situations. You select any number, okay? And then you are to multiply by 6, add 8 to the product, divide this sum by 2, and then subtract 4 from the quotient. And you will notice, what can you say about this original number, and after the whole process, it became 12. And I want you to take a look. 7, it became 21. 11, original number, after the whole process, it became 33. 100, it became 300. Okay? So you will notice that after all these processes, the final number, the final result, is simply 3 times of the original number, right? 4 times 3 is 12, 7 times 3 is 21. So if you multiply by 3, it's pretty much that. So if we're going to make a specific rule, okay, so you select a number, so we do not know any number, so we can use n for it, okay? You multiply the number by 6, so that will be 6n. Add 8 to the product. So if we add 8, so that will be 6n plus 8. And then divide this sum by 2. So we divide this whole thing by 2. So if you see here, 6n divided by 2, that would be 3n. And then you will have 8 divided by 2, that's going to be a 4. And then you have the last part, subtract by 4 from the quotient. So subtract by 4, and you will see that the resulting number would always be 3 times the number n, which is the same as what we have seen earlier. Okay? Thank you.